In 1968, this company was building 150 lathes a week out of a 45,000 square foot factory on Elmstead Road in Essex. No firm in Europe built more turning machines. That year it took the Queen's Award to Industry for export achievement, and its lathes were shipping to American tool rooms under a Michigan badge, to technical colleges across Britain, to any shop that needed metal turned accurately and could not afford to wait for it. That company was Colchester. You are watching Trade Archive. If you were trained on one of these machines, or you still run one, like this video and subscribe before we start. The Hythe, Colchester, 1887. John Ernest Cohen founded the Colchester Lathe Company at Hythe Station Road, in the Port District on the River Colne, where the town's engineering trade had settled. He was not alone down there. Brackets worked out of the same district. So did the Paisley Engineering Company and Woods, a fan maker that would employ close to 1,000 people in wartime. All four firms would still be standing after the depression between the wars, which in Essex engineering counted as a record. The oldest Colchester lathes that survive date from around 1908, and they are small. A 3.5 by 16-inch flat bed, back-geared and screw-cutting, close enough to a Drummond that collectors still confuse the two. On its treadle stand, the machine weighed about 350 pounds. Cohen sold it wherever he could get it sold, and often without his own name on the headstock. The same lathe turns up badged Brown Brothers of London, badged IXL, badged Alfred Herbert, badged Osborne. It sat on the first page of Herbert's small tool catalogue in 1909 at 18 pounds, with 25% off to the trade. The year before that catalogue appeared, Colchester had started building geared head machines. In 1908, the firm took a gold medal at the Franco-British Exhibition, reported in the Times that October. The Franco-British Exhibition was not a trade fair in any modest sense. It filled a purpose-built site in West London that became known as White City, drew millions of visitors across a summer, and hosted the Olympic Games of that same year in the stadium built beside it. A 21-year-old firm from an Essex river port took a gold medal out of it. Alfred Herbert of Coventry, the largest machine tool distributor in the country, put its lathe on the opening page of the catalogue a year later. Then the war came, and the machine tool trade in Britain stopped being a business and became a bottleneck. Artillery consumed shells faster than the country could bore them, and every shell needed a machine to cut it. In the spring of that year, the British Army ran short of high explosive on the Western Front, and the shortage became a political scandal. The government's answer was the Ministry of Munitions, created that June under David Lloyd George, which took direct control of what British factories made and how quickly they made it. National shell factories went up. Existing works were placed under control. Every one of them needed lathes, because a shell is a turned component before it is anything else. Colchester answered with two designs built for one job: a shell lathe and a hexagon turret lathe for shell boring. Neither was elegant. Both were built to run continuously against a production quota set by a government that did not care how tired the operator was. An early mascot from this period went into service with the Royal Naval Air Service. What the war gave Colchester was a reputation for machines that did not stop. That reputation would still be earning the company money 50 years later. Through the 1920s and 1930s, the model names arrived that would outlive everyone who chose them. The Bantam came first in the 1920s, driven by a flat belt, and, in some versions, by a foot treadle. And it became the first machine thousands of British apprentices ever touched. By the early 1930s, the Master was in production at 6 inches by 38 inches, alongside the Triumph at a 7-inch center height, a heavier build for shops that were pushing bigger work. There was a Mascot too, at 6 inches, sharing nothing with the far larger machine that would carry the name 3 decades later. Colchester was a conservative company, and in this trade, that is not an insult. The same basic bed casting, the same slide and lift arrangement for selecting power feeds, carried through decade after decade with only incremental change. A full screw-cutting and feeds gearbox did not become standard until after the Second World War, and even then it appeared sparingly. Colchester built what worked, sold it at a price a general jobbing shop could justify, and let the toolroom specialists fight over the exotic end of the market. In 1949, John Ernest Cohen died. The Times ran the notice that July. He had taken a treadle lathe from a yard by a tidal river and turned it into a national supplier, and the company that carried his town's name was about to be bought by a company that carried a different Cohen's. The Colchester Lathe Company was acquired by George Cohen, Sons and Company, along with the firm's interest in F. Bernard and Company. The Times reported the deal that September. The buyer was not a machine tool builder. George Cohen, Sons and Company, had started in 1834 as a scrap metal merchant on Commercial Road in London, run by George Henry Cohen, and it took the family name formally in 1883. What it had become by the 1950s was the outfit Britain called when something enormous needed taking apart. It disposed of 400,000 tons of surplus shells after the First World War. It brought down the towers of the Crystal Palace, the London tram system, and, at the Festival of Britain, both the Dome of Discovery and the Skylon. The festival structures are worth holding on for a moment. The Skylon was the symbol of the whole event, a steel and aluminium spire standing on cables on the South Bank in 1951, and when the festival closed, the incoming government ordered the site cleared. The spire came down and went out as scrap. The company that cut up the most optimistic object post-war Britain ever built was, by then, the owner of the Colchester Lathe Company. So the group that would hold Colchester for the next 68 years learned its trade demolishing things. That detail sits differently once you know how the story ends. In 1956, a holding company was created to run the group and its subsidiaries. The George Cohen 600 Group Limited, named for the old address at 600 Commercial Road. And in the same year, in Colchester itself, the group set up Gamut Bearings. This is where the lathes got their accuracy. Gamut made super-precision tapered roller bearings, and its signature was a one-piece hollow cage machined from aluminium alloy that kept lubricant moving continuously across the rolling elements. Many of its lines were built to P2 precision as standard, with cone bore runout held between 0.5 and 1.5 microns. The reason a lathe builder cares about that is the load path. A tapered roller takes radial load and thrust load at the same time, which is exactly what a lathe spindle sees when a tool is fed into work at depth. And a taper allows the fitter to set preload rather than accept whatever clearance the bearing came with. Preload is what turns a spindle from a rotating shaft into a rigid one. Get it right, and the machine holds a finish under cut. Get it wrong, and every other tolerance in the machine becomes decorative. The Gamut Works sat directly across the road from the lathe factory, which meant Colchester was buying its most critical component from a supplier it owned, a few hundred feet from the assembly line, built to a tolerance it specified. The group did the same thing with work holding. F. Pratt traced back to 1850, F. Bernard to 1914, and in 1954, the two came together to form what became the largest supplier of lathe chucks in the world. Pratt Bernard International was formalized in a 1974 restructuring, and the 600 Group took the business fully in 1981. Bearings, chucks, and lathes under one roof. Which brings us to the machine that proved Colchester could compete at the top of the trade. The Chipmaster arrived in the late 1950s, and almost nothing about it followed Colchester house practice. It swung about 5.75 inches over the bed, took 20 inches between centers, ran a 1 5/16 inch spindle bore, and made do with 3 HP. Instead of a geared headstock, it used a Kopp variator, a mechanical continuously variable drive built around cones and rollers whose contact point shifts as the operator turns a control, changing the ratio without changing a gear. What came out of it was stepless speed from roughly 35 revolutions per minute up to 3,000. No gear train to select, No compromise between the speed the material wanted and the nearest speed the machine offered. A matrix multiplate clutch handled start and stop. The spindle ran in gamut super-precision bearings. For a tool room, stepless speed is not a convenience. It is the difference between the surface finish you calculated and the surface finish you settled for. That combination put a small British tool room lathe into a conversation that had previously belonged to Monarch and Harding. One long-term owner described the difference between a Chipmaster and a Monarch 10EE as the difference between a 1950s Rover saloon and a Cadillac. Economized, obviously economized, and still accurate enough to earn its floor space for 50 years. The Chipmaster also had a second identity. Colchester built it, and Harrison sold it as the Harrison 10AA. Two of the most respected names in British lathe manufacture, one machine, and owners of either badge still reach for the other's manual when something needs setting up. But the Chipmaster was never the business. The business was volume, and volume happened on Elmstead Road. Start with the bed, because everything else hangs off it. Colchester poured heavy cast iron and then took it through the grinding bays, where photographs from the period show lines of beds waiting their turn on dedicated grinders. Then the ways were induction hardened, and a sticker went on at the tailstock end to say so. That process is the single reason so many of these machines are still working. Owners who have run them for decades report that the hardened iron beds simply do not wear out in normal service. Gears were generated on dedicated gear cutting machines, main spindle gears and gearbox gears alike, which is why a Colchester headstock at full speed announces itself from the other end of a workshop. Nobody ever claimed they were quiet. Assembly ran on a moving floor. Sub-assemblies fed the line. The floor carried the machine forward through each station, and sections of that floor were craned back to the start to begin again. It was automotive practice applied to gray iron, and it was a deliberate break from what Colchester had been doing only a few years earlier. In the early 1950s, the same work was still being done by hand, with a headstock sitting on the floor and electric motors laid out on a fitting bench, assembled by men who fitted parts to each other rather than to a drawing. That distinction decided everything downstream. When a fitter marries two parts by scraping and adjusting until they suit each other, the machine that results is accurate and unrepeatable, and the spares that fit it are the ones that were fitted to it. When parts are made to a drawing tightly enough to be interchangeable, the fitter stops being a craftsman and becomes an assembler. Output multiplies, and a customer in Perth can order a component by number 20 years later and bolt it straight on. Colchester chose the second, which is why parts for these machines are still available, and why the trade still talks about them as a range rather than as individual survivors. The flow line is what took the company from a good regional builder to 150 machines a week, none of which would have mattered if the machines came off the end inaccurate, so Colchester tested them in a way almost nobody else bothered with. Through the 1960s and 1970s, larger machines left the factory with more than a standard inspection sheet. They carried a certificate showing the results of a sample turned on the machine and then measured on a Rank-Taylor-Hobson Talleyrand, an instrument that plots deviation from true roundness down to 100,000th of an inch. Inner plates for the screw-cutting gearboxes were checked for flatness on Ferranti visual testers. Mascot spindles went onto a linear readout tester for roundness before they went anywhere near a headstock. By the mid-1960s, the model range had settled into the shape most people still picture when they hear the name. The Bantam sat at the bottom, still the machine an apprentice met first. The student was the training lathe proper, hardened bed, gamut spindle bearings, built to survive a room full of 16-year-olds, and it also went out under the Dominion badge. The Master was its longer bed sibling, and the Master 2500 pushed the top speed higher. The Mascot 1600 covered heavier work. Above that sat the Mastiff, and above that the Magnum, a machine large enough that most shops never needed one, and the ones that did never bought anything smaller again. Read across that list, and you can see the commercial logic. A shop bought a student because it was cheap and it was what the new hire had trained on. When the work outgrew it, the next machine up used the same controls, the same handwheel logic, the same feel. Colchester was not selling lathes. It was selling a ladder, and every rung had already been climbed by somebody in the building. Pay attention to this next detail, because it explains how a factory in Essex ended up equipping half of American industry. Colchester sold into North America under the Closing name, and later as Closing Colchester. Closing had begun in 1911 in Kalamazoo, Michigan, as the Atlas Press Company, built around arbor presses patented by Gardner T. Eames. It was not a heavy lathe builder. What it had was a distribution network and a reputation across the American Midwest, and what Colchester had was product. The badging worked by swing rather than by name, so American machinists never learned the British model names at all. The student went out as the Closing 13-inch, the 8010 series. The Triumph became the Closing 15-inch, the 8030s. The Mascot became the 17-inch, the 8050s. The Mastiff was the 21-inch, and the Magnum the 25-inch. Underneath the American paint, the maker's plate still read the Colchester Lathe Company Limited, England. In February 1968, the first production Triumph 2000 was built, and it looked like nothing Colchester had made before. The Science Museum's record calls it a revolution in styling and specification, with distinctive square styling, ergonomically designed controls, and a bright exterior finish. The rounded agricultural look of 1950s British machine tools was gone. What replaced it was a machine that announced its top speed in its name and looked, for the first time, like it had been designed rather than accumulated. The other thing that changed in this period was where the machines went. From the 1950s onward, Colchester ran a deliberate export campaign, and it worked well enough that the domestic market stopped being the point. Machines went to Commonwealth shops that had inherited British practice and British thread forms, to European general engineering, and into the United States through an arrangement we will come to. A lathe built beside a tidal creek in Essex was being uncrated in Lagos, Auckland, and Kalamazoo, and the Queen's Award exists to mark exactly that kind of trade balance. 1968 was the peak year in every direction. 150 lathes a week, 45,000 square feet. The largest manufacturer of turning machines in Europe, and the Queen's Award to industry for export achievement to prove where they were going. There is a reason those numbers were possible, and it has nothing to do with the machines. Britain in the late 1950s and 1960s was building apprentices at industrial scale. Company training schools opened, and day release schemes expanded, and in 1964, the Industrial Training Act put a structure under all of it. Industry training boards were set up, employers paid a levy, and firms that trained properly claimed grants back against it. Training stopped being a cost a company absorbed out of goodwill and became a line an accountant could defend, and a great deal of that money went straight into equipment. Every one of those training rooms needed lathes that were accurate enough to teach on, cheap enough to buy 40 at a time, and tough enough to survive being crashed weekly by someone learning what a crash felt like. The Colchester student was the answer so completely that the trade nicknamed it the Ford Fiesta of lathes. That is the arrangement that carried Colchester through 2 decades. Sell the same machine to industry and to the schools that trained the people who would buy the next one. And those training rooms were not gentle places. The danger that machinists talk about most is the one that sounds least dangerous: using a strip of emery cloth by hand to polish work turning in the chuck. It was done because it worked. A turned finish carries tool marks, and a few seconds of emery brings a shaft up to something a bearing will accept without a second setup on a grinder. So the apprentice reaches in with a strip of cloth between finger and thumb against a component turning at 4 figures. The British Health and Safety Executive still publishes the outcome in plain language, stating that every year there are serious accidents involving the use of emery cloth on metalworking lathes, resulting in injuries such as broken bones, dislocations, lacerations, amputations, and occasionally death. The cloth catches, wraps, and takes the hand with it, and the spindle does not notice. The trade's answer was a rule that sounds like superstition until you understand it. You file left-handed. Not because it is comfortable, but because if the file catches and throws, a left-handed grip sends it past you instead of into you. Reaching over a spinning chuck with your right hand was the kind of thing that got an apprentice sent off the floor. Then, there is what happens when a heavy chuck lets go. One account from a technical college describes a carriage run into the chuck on a 13-inch Colchester at 1,200 revolutions per minute. All 6 cams sheared, the chuck came off the spindle, bounced along the ways, glanced the operator in the face, and took a chunk out of the concrete floor. He kept his eyesight. The floor did not recover. These were the machines Britain trusted to teach 16-year-olds a trade, and they were rigid, hardened, accurate, and entirely capable of killing the person operating them. Everybody on that floor understood both halves of that sentence. That understanding is built into the product. A training lathe is not a cheap lathe. It is a machine specified on the assumption that it will be misused daily by someone who does not yet know what he is doing, which is why Colchester put hardened ways and super-precision bearings into a school machine at all. The hardened bed absorbs the crash. The gear train, loud enough to be heard across the room, tells an instructor at the far end of the shop that something is loaded wrong before he can see it. Those choices cost money on a machine sold on price, and they are the reason so many of these lathes outlived the colleges that bought them. The 1970s tested the arrangement rather than the machines. From the first day of 1974, with coal supplies choked, commercial users across Britain were restricted to electricity on 3 specified consecutive days a week. Factories that had spent 15 years engineering continuous flow production were told which days they were allowed to run. The wage restraint agreements between government and the unions carried the middle of the decade before collapsing into the strikes of the winter of 1978 into 1979. A factory turning out 150 machines a week depends on iron arriving, power staying on, and finished lathes leaving on time. Through that decade, none of those 3 could be assumed, and the flow line that had made Colchester the largest builder in Europe was the part of the operation least able to absorb a stoppage. A hand-fitting shop can catch up. A moving floor cannot. By 1979, the 600 Group had bought Gamut bearings outright, and by 1981, it held Pratt Bernard as well. On paper, the group had never been more complete. Bearings, chucks, lathes, and by 1986, its own American distributor. That year, the 600 Group bought Clausing Industrial from Rex Nord of Milwaukee. Clausing moved into a new building in Kalamazoo around the same time, and by then, its direct manufacturing employment was down to around 30 people. The badge had outlived the factory behind it. That pattern was about to repeat itself on the other side of the Atlantic, at a scale nobody in Colchester was ready for. The pressure came from 2 directions at once, and only one of them was cheap labor. The other was the control. Through the 1980s, computer-controlled turning centers moved from the aerospace end of the market into ordinary jobbing shops. A machine that held its own dimensions, ran unattended, and repeated a component 500 times without an operator touching a handwheel changed what a lathe was for. The skill migrated off the shop floor and into the program. A Colchester student was still the best way to teach a 16-year-old what steel does under a tool, but the number of shops that needed 40 of them fell every year, and the number that needed 1 skilled turner instead of 6 fell with it. Then came Taiwan, and then mainland China. Cast iron machined to acceptable tolerance, shipped into Europe at prices a factory in southern England could not touch. The Victoria County history records the outcome plainly, noting that new firms abroad had developed their own lathe-making capacity to supply their own markets. Colchester still employed around 500 people in the town in 1987. In 1992, it stopped. The closure was raised in the House of Commons that July, where the record notes that the Colchester Lathe Company had announced its intention to cease production. 105 years after John Ernest Cohen opened at Hythe Station Road, the town that gave the machines their name stopped making them. The Hythe had been an industrial district since before the company existed. Engineering had been the reason the district had work, and the Lathe Company had been the largest of the firms that made it so. What replaced that employment was not another manufacturer. The brand did not die. That is the part that still divides opinion in the trade. The same year, the 600 Group merged the Colchester Lathe Company with T.S. Harrison and Sons, the Yorkshire firm founded in 1898 by Thomas Strickland Harrison, and formed 600 Lathes. Manufacturing moved north to Heckmondwike in West Yorkshire. To hold a price against the imports, the group did the arithmetic every British manufacturer was doing in the 1990s and began sourcing castings and heavy machining from Taiwan and later from China, including the Dalian Machine Tool Group, with final assembly and finishing kept in the United Kingdom. Which is why, 30 years on, the first question in any used machine listing is where the iron came from. Essex-built Colchesters carry a premium. Buyers check for import marks before they check the spindle, and they will pay more for a 50-year-old machine with a hardness sticker at the tailstock end than for a younger one with a shorter journey behind it. The name survived the factory, and a section of the trade has never fully accepted the trade. Gamut outlasted the lathe works by a long way. The bearing business, the 600 Group set up in 1956 to feed one factory's spindles, was still running as a specialist supplier decades after that factory closed, and in 2019 it was bought by HB Bearings of Huddersfield. The component that made the machines accurate now has a longer continuous history in British ownership than the machines did. The Elmstead Road site was cleared and sold for retail. A Tesco superstore was built across the ground, and the estate road that runs through the site was named Mascot Square, which is now the most substantial memorial the company has in the town it was named after. Bob Russell was elected Member of Parliament for Colchester on the 1st of May, 1997, and used his maiden speech in the Commons that month to attack the way the lathe works had been closed and the land disposed of. The machines kept coming. In the 1990s, Colchester moved into computer control with the Tornado series of turning centers, machines like the Tornado 100 and 200 running Fanuc controls, and later the 210 and 220M with Fanuc 21 IT and driven tooling. The bed philosophy did not change. Heavy cast iron, ground and hardened, with a control system bolted to the front of it. In 2009, the group merged 600 Lathes and Pratt Bernard International into 600 UK, and in 2018, the business rebranded as Colchester Machine Tool Solutions. It operates from a purpose-built site at Lowfields Business Park in Elland, West Yorkshire, run as a technology centre rather than a factory in the old sense, with a demonstration showroom where machines are put in cut in front of the buyer, development facilities, and a spares and work-holding inventory valued at over £5 million. Around 400 distributors carry the range into more than 50 countries. There is a laser marking division as well, trading as TYKMA Electrox, which puts the company into a process it had nothing to do with when it was grinding beds on Elmstead Road. The lathes themselves split two ways. The Typhoon and Storm machines are conventional computer-controlled turning and machining centers competing on the same terms as everyone else. The Colchester Multi-Turn and the Harrison Alpha are the more interesting half. They are manual lathes with control layered over the top, so a turner can work them by hand wheel exactly as he learned to, then hand a repeat job to the control and let it cut. That is a machine designed for a shop with one experienced man and no programmer, which is to say, the same customer who bought a student in 1968, still being sold to under a different name. On April 8, 2022, the Machine Tool Solutions division was sold out of the 600 Group entirely. TJM Capital Partners bought it through an acquisition vehicle called Time Savers Acquisition, in a deal reported at around $21 million, taking both Colchester in Britain and Closing in Michigan. Managing Director Jonathan Wright and Closing President Kevin Mungavin stayed on. In March 2023, the buyer organized its manufacturing holdings under a platform called Encompass. Colchester and Closing now sit there alongside Bourne & Koch, Bridgeport, Newman, Mollert, Randbright, Dubois Equipment, and Time Savers. Pratt Bernard went into the same portfolio, which means the Chucks and the Lathes ended up back together after everything else came apart. Read that list of names, and you are reading a graveyard of independent machine tool builders, British and American, assembled into one balance sheet. Every one of them was somebody's family firm. The British company that had been owned since 1954 by a London scrap metal dynasty is now owned by American private equity, and the two names that fought over the American market in the 1960s are finally in the same portfolio. Roughly 1 million conventional Colchester and Harrison lathes have been built across the history of the two firms. An estimated 100,000 are still turning metal today, and something close to half of those are in training use. Think about what that second number means. A machine designed in Essex in the 1960s, on a flow line that no longer exists, for an apprenticeship system that no longer exists, is still the first lathe a large share of the world's machinists ever touch. The company was closed. The product was not. Which brings us back to Mascot Square, a road name on a retail park running over the spot where the moving floor used to carry headstocks toward final assembly, 150 times a week, in the best year the British machine tool industry ever had. The supermarket has the postcode now. The machines are in workshops on 6 continents, still holding tenths, still running on bearings made across the road from a factory that no longer exists. If you want more of these stories, subscribe to the Trade Archive. There are many more like this one on the channel.